whatever.
Maybe I got it.
Yeah.
Light is.
Your question was, is blue color brighter than other colors?
Maybe light is the amount of energy coming out of a source.
Cheta, yes, you're right. But when more energy is coming out, is it brighter?
Yes. Yes. That's my answer.
You understand what the confusion is about?
Yeah. I know.
His question was, is blue color brighter than red color?
Yeah.
So first, let's say you are putting 10 watts in blue color and 10 watts in red color. Okay, same amount of energy is given to the both LEDs.
Right.
Which one will appear brighter? That is one question that you can have, right?
Right.
If you use exactly same identical LEDs, you put 5 volts in both of them, and then you see the LEDs glowing. If you see one of them will be brighter than the other one, then you can say that, oh, blue color is brighter than red color. But you cannot say that, because when you look at those colors, they'll almost be like, there is nothing like brighter or less bright if the energy consumed by them is same. So what happens is, do you know what's a charge particle, or like something? Anything can have charge, right?
I've heard of it.
So scientists told that when something has a charge, it emits something called as electrical field. What does that mean? Is that it's very crude, okay? Like when you have a charge, okay, let's say a positive charge or something, the electric fields go in all direction, like this, okay? This is your electric field. Then when you start moving this charge at a fixed velocity, you know what happens? Wanna guess? It makes magnetic fields. What it means is that if I start moving the same charge, now the charge is like this, basically this whole thing was the trajectory. So there will be the magnetic field like this, which are given by a like this some like law. Feeling sleepy? Wake up.
No.
Okay. Makes sense. So when electron is moving, it produces magnetic field. When electron is stopped, it produces electric field.
Why is it spiral?
Why does it spiral? It's math. You can check that. There is a guy called what's his name? Maxwell. He wrote these equations, and so basically he identified some rules according to which the universe is working, and he wrote that mathematically, and he wrote 4 equations that gives us the relation between electricity, magnetism, and light. How they are same thing. How they are literally the same fucking thing.
They're the same thing.
They are the same thing. I'll tell you how. So when when the charged particle is moving with a constant velocity, it produces a magnetic field. What does that mean? You take a wire, you put some current into that wire will become a magnet. How do we know? You take a compass near that thing, you'll see the change in the magnetic field. You can do this, like on your phone, open the compass app, you turn the electricity and you turn the electricity off, you'll see like something is changing. I don't know if this is going to happen in such a small current, but let's say if this is the wire, take the circuit off, take the wire from there, not significant enough current, okay, turn it on, put it on, not enough current, but you know what I mean, huh?
Insulation.
Yeah, a lot of things going on, and it's supposedly not move like that, because I would assume that it's like good compass that is not changing like this. Okay, now the question is, guys, what happens when it is stationary? V equals to velocity equals to 0. Okay, when it is moving, V equals to non-zero. Like when it is moving, what happens when it is changing velocity? You know what I mean? What is velocity?
Speed? Like how fast you're going?
Fair enough. But what is the difference between speed and velocity then?
Speed is how fast you're accelerating, right?
Nope.
How fast you end, like the end speed, how fast you're going.
Nope. Let's turn that off.
Uh,
Nope. So do you know like there is a difference between speed and velocity?
is there?
Yeah. It's fundamentals and like you should be learning about. So when do you say something has velocity or speed? When it moves? When what do you mean by it moves? That at t equals to some time it was here, and then t equals to some different time it was
Right.
here. Okay, you know the difference between that time, and you know how much it moved, so you know that that is the velocity or speed. Okay. Now my question is, you understand the formula of this thing, right? Distance covered upon time is your speed or velocity.
Right.
Now my question is, let's say a person starts from this point A, okay, and he or she goes to point B, which are 60 miles apart, okay, and they did this in 1 hour. What is the speed?
60 miles an hour.
Right, because they covered 60 miles an hour. Okay, how do we know that A and B are this apart? Now the question is, guys, if A is here
Uh-huh.
and it comes back to the same point,
Right.
now apparently the distance between both of them, A and B, is 0. Make sense or not?
Mm-hmm.
So
Yeah.
would you say the speed was 0?
Oh. Okay.
No.
You're saying.
I wouldn't say the speed 0, right?
See, that's why we need a new term.
Oh, okay. So what? That's what velocity is.
Yes. A velocity is speed with a direction. That I am moving.
Yes, you're right.
I'm moving with this speed 5 meters per second or 60 miles per hour
Yeah.
in this axis. If you
Yeah.
don't specify this, it's speed. If you specify this is velocity. And why this is important? Okay, this our question was, first we have a charged particle. A charged particle has what? Something called as an electric field. When we move that particle, what we have a magnetic field. Now my question is, when you change velocity, and now you know change in velocity can be done by two ways. First, by changing the speed, or
Changing your direction.
yes. And do you know how smart this thing is? The food that you just ate is working on the same principle. So what happens is, when you change a velocity of something, it emits both electricity, electric fields, and magnetic fields. However, those electric fields and magnetic fields are produced in a very specific way that is unique to our universe. It might be different in some other universe, but it's unique to our way. How it happens is, let's say this was the electric wave, and now what does that mean? Electric wave. Okay, what I'm saying is, when you move an electron or some charged particle and change the direction, which basically means if you do this, first the charged particle goes from top to bottom and then goes back. You change the direction, right? Even though they are doing this at a constant speed, let's say 60 miles per hour, but their velocity is changing. You see, like the direction changes, velocity changes. So let's say if something like this is happening, okay, a charged particle is moving up and down, it creates light. We cannot see that light because it's moving very slowly, but what it means is, if this is moving up and down, the electric field will be moving up and down. So let's say this is the electric field that is moving. The magnetic field will be moving like this, perpendicular to it. So the magnetic field, and this is the diagram you'll see a lot of places. It's difficult to draw. You see, this is in this axis, this is in a different axis, and this is different axis. X, Y, and this is the travel, like wherever the wave is traveling. So X is electric field, this is magnetic field. What does that mean is the moment you change the direction of a particle, right? That change in direction was the particle didn't like it. Basically, what's Newton's law? That anything that moves in this universe should be moving unless you disturb it, right? So charged particle wanted to move. First, it didn't want to do anything. It was just existing in space. So it was giving you what? Electric field. Now you put some electricity on it and it started moving. So it produced magnetic field. Now you change that electricity. So first you were having plus and minus like this. So the electrons were flowing like there. And then you changed it after like some seconds. Now the electrons are moving there, and then you change it again, and you do this again and again. The electrons are doing this again and again. Every time when it changes direction, it emits something called as a photon. Photon is the packet of light. I don't have answers to a lot of questions, neither do a lot of scientists right now, that what exactly photons are and all. We can go to very deep level, but we don't exactly know what a lot of things are in this universe. Okay. Now the question is blue brighter color or not? Right? When you move these electrons up and down, right, based on how fast you are moving, this will be changing how fast this wave is moving. But what I tell you, or what Maxwell told you, is, or Einstein told you, or a lot of people have told, the speed at which this thing will travel is always constant in this universe
The velocity.
of light. No, there comes speed of light. Doesn't matter direction, doesn't matter whatever. This wave, whenever it's produced, it will travel in this universe with the speed of light. Okay, which is 3 into 10 raised to power 8 meters per second. It travels 3 into 10 raised to power 8 meters in 1 second. That's fast how light is. Okay, now the thing is, if you know that this thing is constant, if I tell you that for a wave, if it is moving like this, if I tell you that what is this length, like one oscillation, what is this length? Okay, let's say this is 1 meter. Okay, and this is traveling, this wave is traveling at 2 meters per second. This wave, okay, this is 1 meter and this is 2 meters per second. It's traveling like 2 meters per second. Every second, how many of these full waves? So this is a full wave. I can take this and put it here, put it there. This is what is repeating, right? This is like the smallest amount of wave that you can cut out of this thing. How many times this is repeated every second? You know what I mean by that?
How many times is it repeated every second?
Yes. If this thing is traveling in 2 meters every second, and this whole thing is 1 meter apart, how many times that thing is? What I'm basically in terms, I want to ask the frequency. This thing is called wavelength, length of that wave.
Yeah.
And I want to ask how many times this wave is going up and down. Every
Two
second.
meters.
Huh?
2 meters?
If 2 meter per second is the speed
2
or
meters
velocity.
per second, and then it's 1 meter. So 2 meters per second, 1, 2. So it's 2, right?
Yep.
Yeah.
Simple. Like 2 times it will vibrate every second. That's how it travels in. Okay. I told you that this thing is fixed. Speed of light is constant. So what happens is, guys, there are two things: frequency and wavelength. If you increase the wavelength, the frequency has to decrease. And if you increase the frequency, the wavelength has to decrease. Make sense? If speed is constant. Okay?
Yeah.
So far so good. Any question so far? Like tell me what I can.
So
Yeah.
what I got from that is that. Sorry, you said wavelengths.
You're going to take an Arduino home. That's why like you can.
Yeah. You want me to take the...
No, you'll take the breadboard.
You want me to take out?
You'll take the breadboard and some of the components, so you can create the circuit yourself. You don't have to.
circuit?
We'll see, like
Oh.
basics. Like
Oh, it's like a basic.
take this thing.
What the heck is that?
Huh?
What is that?
You have to figure out. Do something with it.
So velocity is like speed and also direction, and then at the direction it goes is always constant. It's the speed of light, and then something about the length of the wave segment, right?
So, for instance, I'll tell you, blue light has a wavelength of roughly 470 or 490 nanometers. Nanometer is a very small thing. Okay, what it means is the one wave, this thing is 490 nanometer. Now, can you tell me how fast this has to move up and down? Like basically, what is the frequency?
Well, very, very high.
Yeah,
Right?
for
It's
sure,
really-
for sure.
really
It's in
oscillating
gigahertz.
very-
Yeah, maybe more than that, but still, what?
Still.
I mean, roughly, like give me an order or something. So, okay, in general, whenever you do something like this, right, make it easy. 590 is roughly what? 500.
Mm-hmm.
Let's assume 500. 500 nanometers. So basically 500 into 10 raised to power what meters? Nano is what?
Is it not?
9. Did you know about this?
Uh,
So meter is, let's say, 1. Kilometer is what?
2.
No.
Oh.
1000 meters is 1 kilometer.
Oh,
Right. So a millimeter is what?
0.
How many times you have to divide a meter
Yeah.
to make
Six.
1 millimeter?
Right?
Huh?
6?
Nope.
Sounds like
Is it 2?
it's million.
What?
It's a million.
No, the question is how many times do you have to
Oh,
divide a
sorry.
meter?
It's 10 to the 6th power though.
No. How many times do you have to divide a meter to get a millimeter?
1 million. 1 million.
Something like that.
It's 1 million
Yeah.
meters.
You know what I mean, right?
Yeah.
So
I
a
know
meter,
what
let's
you
say
mean.
if this big, okay, a centimeter is when you divide this by 100,
Right,
like
yeah,
100 part, and then when you divide it by 100 more parts, 100 no, 1000 more parts. Wait, I got confused.
Millimeter is
10 raised to power minus 6. That's we know.
yeah 10 to the minus 6.
Minus 6. Okay.
Right.
So nano is 10 raised to power
Negative
minus
9.
9.
Yeah.
Okay. So you roughly can calculate the frequency of it. Okay.
Mhm.
Now what happened, guys, is you have a metal plate here, and a lot of scientists were doing this experiments, but they were getting confused that you have a metal plate here. They put some electricity around it, very tiny amount of electricity, or they are measuring electricity, okay, on a metal plate, and when they shine light, they feel something, a voltage and all, and then they were like, oh, let's call this photoelectric effect. Photons like light, and
Yeah.
electricity, photoelectric effect. So we want more electricity. So what they want, let's use 2 bulbs. Makes sense, right? Like if you want more electricity, instead of using 1 bulb, use 2 bulbs. So electricity should be double. It didn't happen. Let's use 4 bulbs. Didn't happen. Einstein had to come in, and he said, just by increasing the bulbs, you are only increasing the intensity of lights. Intensity of light is number of those photon particles per second. Okay, you are not changing how much energy each photon is capturing. Does that make sense?
Okay.
So when you are talking about red light, its energy of a photon is less than what a photon of blue light can carry. Does it make sense? So is blue light brighter? Question is meaningless. Blue light has smaller wavelength or higher frequency or more energy than red light. Okay, so these, any questions so far?
Okay, what I got so far is that since there are more waves per segment of blue light than red light, it's a higher wavelength, but that doesn't necessarily mean it's more powerful because, like the intensity of those waves is different at different voltages.
So let's say you have one bulb, that is producing blue light.
Yeah.
You know blue light is 490 nanometer. That bulb produces 5 photons every second. Okay, so that is the amount of intensity you are feeling of blue light. Now you will put two bulbs, so you will get 10 photons of blue light. You will see a brighter light, but still blue color light. What I'm trying to say is Einstein came in and he says something that you have an atom, electrons are moving around it, light falls on it, packet of energy. That packet of energy is used to do two things. First, take the electron out of that atom, which requires some energy, which is a fixed for every atom, every electron, okay, based on the configuration. And what is the extra amount of energy that is left? So, if you have, and then there is a Max Planck guy who gave the formula of this thing, HF. H is Planck's constant. It's a number, very small amount of number. F is the frequency of the light. For instance, in blue light, whatever the frequency will be, red light, whatever the frequency will be. So now you know, like the bluer the light is, the more frequency it has, and this is the formula of energy of that. H into frequency. So the more frequency you have, the more energy you have in that light. Okay, it is used as Hc naught plus half mv square. What does that mean? First term, Hv naught, V naught, F naught, for every atom or every whatever you want to take the electron out. This F naught term we already know. For instance, when you make a battery, right, that 3 point something volts is because of the chemistry of that battery. So these chemistry things we already know, that how much energy we need to take the electron out. Okay, so let's say if we are giving two amount of energy here, then one is going here, so one is remaining, and that is the speed at which the electron will be ejecting. Make sense? So now to increase the speed of that electron that is ejecting, what are you supposed to do? Are you going to put will you be putting more light, or you are going to change frequency of light?
Frequency.
Because if you change frequency of light, we will have more energy. When we have more energy, little bit is used to take out the electron, rest of it is like shooting the electron like a gun. Okay, now the thing is, Tom, what we are talking about is from 490 to 900 nanometers that our eyes can see. Okay, where in this direction the energy will increase. The smaller you do the wavelength, the energy will keep on increasing. Does it make sense? Like to make something vibrate even faster, you need more energy. Let's say here less energy. So your radio waves, the microwaves and all, they come in this spectrum. You can't see them. They're all light. They come in this spectrum. After your blue light, it comes ultraviolet, then it comes X-rays, then it comes gamma rays. That's how you keep on increasing the energy. You know, that's how then. Okay, so now you understand, when you change direction of a charged particle, you get EM waves, which is basically some sort of light. Okay, so to get light as like this form, you just basically heat something up, like tungsten and all. It vibrates so much that the vibration is of the frequency your eye can see, so you get like glow.
Okay.
Now you want to make X-rays. What is X-ray? X-ray is a form of light, which much higher frequency. How would you make it? What do you think? How can you make X-rays?
Heat it up even more.
That is one way. But when you keep on heating up, there is a limit. The whole thing just breaks apart.
Okay.
So there is a limit to how much you can heat something up.
Oh.
How do you produce EM waves, guys?
You just heat something up, right?
You change the direction?
You change the direction. You change the velocity basically.
Okay.
You change the velocity. Velocity can be changed by what?
Two
Things, direction or speed, right? If you change the direction, velocity changing is one way that you can do to make radio waves and all. What they do is they have a tube in which electrons are moving like this. So you can imagine like electrons are changing direction, right? That's how they're producing like your EM waves, radio waves in your microwave. But you cannot produce X-rays like this. The amount of speed at which you have to revolve these electrons is like insanely high, like next to impossible. Think about it. You have to change direction of something really, really fast. What is the fastest way you can change direction of something in your head? Or change the velocity of something? Or accelerate something? Acceleration is change in velocity, right? Yeah. Think about it. If you crack this thing, you'll be proud of yourself. I've given enough hints. You need to produce an EM wave of very high frequency. Okay. We know EM waves are produced when you change direction of a charged part. When you change velocity of a charged particle.
What about changing the speed?
Yeah, I said that. Velocity has two components, right? Speed or your direction. So you can do both.
Yeah.
Okay. How can you change speed of an electron or something?
If it hits something, right?
Okay, then what?
So if it hit like if you're doing for like an MRI, it would hit your bone, and then you would see an X-ray, right?
This is how X-rays were invented actually.
Right.
So what they did was, you have a fast moving electron, you have a plate of let's say lead or something.
Yeah.
What happens is, you shoot that electron, it hits this plate, the electron cannot cross that plate, so from a very high speed, the speed is suddenly what? Zero.
Okay.
That's change your speed. The moment that happens, on the other side you get X-rays.
Oh, okay.
You see how intuitive that is?
Yeah.
That's crazy.
This is fucking world, man.
That's cool.
Microwaves are invented, like he was just experimenting that what happens. So what I told you, let's say a lot of scientists knew that in 1900s. 1850s was the time, let's say, people figured this out. I'm talking about like 200 years ago. Now what they will be going to do? There are so many things to try, right? So Einstein came in, he told that okay, you can increase the power by changing the color of it. Let's change the color of it. What we can create X-rays, how can we create gamma rays, how can we do that? Just opened up a plethora of all those experiments. All because they understood the concept that you both understand. If you were a scientist at that time, you might have invented X-rays. You might have invented X-rays. Like someday you are like just sitting and thinking like changing direction, changing. Oh shit, what if I? Literally, it was invented like this. The guy was like, oh, if I just stop the electrons' movement, I will have a lot of energy on the other side. So he did that. He got X-rays. And RF radio waves, they were doing the same thing. They were moving the electrons very fast.
Yeah.
You can't see radio waves, you can't do anything about it. But he had a chocolate bar in his pocket. The chocolate bar melted. And he was like, oh shit. That's how microwaves were discovered.
Wait, the chocolate bar melted because what?
Because he was experimenting with microwaves. They were all over the place. They melted the chocolate bar in his pocket.
Oh.
That's-
Also, it is definitely like 5:36.
Okay.
So
let's go.
what did you want me to do? With
Yeah, sure. So this is a sensor called ultrasound sensor. Have you seen this or read about it?
No.
So one side throws sound,
Okay.
one side gets the sound back.
Okay.
Okay. So you just need to show that or make. I don't know how far you can go. Okay.
Okay.
You just have to use this to do something. Like either you can show the values on the Arduino, or you can show that on a graph, or you
Okay.
can change the color of it or in brightness. You see, like based on
Yeah,
how
just like
good you
fix
can
it.
code. Yeah. So what you would be needing is you would be needing an Arduino.
A breadboard, some jumper cables.
Take two Arduinos because we don't know if that's working. Okay.
I got some jumpers. So
Yeah. Take everything. Let me
Resistors.
fill up the air in the car so that I can talk you. Oh, you come back, Otto, but you don't want to guess.
Yeah. I gotta go buy cheap gas soon. I'm on empty.
here's jumpers. Here's some jumpers.
Your jumpers. So okay, one thing I would say. Do you have scissors in your house?
No, I don't.
You don't.
I have knives. I have to cut
Can
it
you
off.
bring scissors back?
I can bring it back on Monday.
So
Or-
take
I got scissors.
one of these, okay?
I'll get you scissors. Oh
I
no!
didn't make
Wait,
one.
no.
You can make your own jumper.
Yeah,
So
specific
you
one.
basically
This stuff works?
Yeah, this works. I hope. Just the few things. Don't try to break it when people cut something which is not to be cut from this.
Mhm.
It damages. So okay, this is what some gauge of wire. So put in the right one. You'll feel it, and you cut the whole shit off. So you use a lower one. Okay. So you can make your own jumper, whatever size or whatever.
Okay.
Okay.
Alright, it's beautiful. And this is the spool there.
You need a cable for this. This is a standard printer cable.
Yeah.
Do you have that? It's a printer cable.
No, I don't have that.
Let me fill the air first. Tom, can you find him a arduino cable?
Arduino cable?
Um,
I don't know what those look like. I'll fill the air for you. How about that?
Did we talk about 1 hour? No. Stop.
Is your car unlocked?
What?
Is your car unlocked?
Uh,
I'm gonna go fill your air.
here.